Okay, well, hello everybody there. How you guys doing? Hopefully you're going to be watching this video real soon so you don't fall behind in class. I emailed you guys the other day and I told you guys that we're going to take our test over Chapter 2 on the Monday you come back, which is what, the 16th, I believe it is. So we'll do that. In the meantime, though, we are going to move on to new material and we're going to start Chapter 3. Okay, so your test is still over just Chapter 2 stuff, but you are going to start Chapter 3. We're going to start with Section 3-1, and Section 3.1 is not that bad of a section. I think you'll find it not too difficult. So anyhow, Section 3.1, just a couple of notes real quick. We're talking about functions, okay? Section 3.1 deals with functions. Now, before we talk about what a function is, we need to talk about what a relation is. Okay, a relation in algebra is when you just have ordered pairs. For example, if I had 1, 7, 3, -4, 8, 2. Okay, that's a relation. You know, x, y, x, y, x, y. 8's with 2, 3 is paired up with -4, 1's paired up with 7. That is a relation. Now, that's also something called a function, okay? A function is a special type of relation, okay? And that's where every x is paired up with only one y value. For example, this x value 1 is paired up with only 7. This x value 3 is only paired up with one y value, -4. And this x value 8 is only paired up with one y value 2. Now, if I was to throw in this right here, 311, this is no longer, it's still a relation, but it's no longer a function because this 3x value is paired with -4 and 3 is also paired with 11, okay? So that would not be, it'd be a relation, but it would not be a function, okay? Now, if I made this into a -3, then it's a function, okay? Then it would still be a function. Now, be careful. Some students get thrown by this. If I gave you 8, 11, no, not 8, let's make it -8, 11, okay? This is still a function. Now, if you're going, well, 11's with 3 and 11's with -8, that's every y has one x value. That's not what I said. I said every x has to have one y value, okay? So this would still be a function. I changed that to a -8 because if I would have made it a +8, then it wouldn't be a function because 8 would be with 2 and 8 would be with 11, okay? So that's what a function is. It's a special kind of a relationship, or not relationship, a relation, where every x is paired up with one y value. Okay, a real world example of it would be when you have to take a test. You're going to take a test in about a week and a half or so. That would be a function because every student gets exactly one test score. When you take your test, if I said, oh yeah, your test score was a 83% and a 72%, your response would be, well, which is it? Is it 83 or is it 72? It doesn't make sense, okay? So every person has one test score. Now, does it work the other way? Does every test score go to one person? Not necessarily. If a test score is 92, it may not go just to one person. It might go to 2 different people or 3 different people could get 92s, okay? So every person has one test score, but every test score doesn't necessarily have one person, okay? So every x has one y value, and that's what a function is, okay? Now, there's a few other things we have to talk about when we're dealing with functions, okay? And we're going to explain that as we work through the problems. Just like always, we're going to work through half the problems together, and then the rest of the, you'll have to figure out on your own, okay? So when we look at exercise 3 on section 3.1, okay? They give us the points 1, -2, 2, 1, 1, -2, 2, 1, 1, -2, 2, 1, 3, 6, 4, 13, 3, 6, 4, 13. And what else? 522, 522. And they ask us, is this a function? Well, what's 1 paired up with? Only this number. What's 2 paired up with? Only this number. 3, 4. Every x only has one y value. So this is a function. This is definitely a function. Okay, it's a relation, and it's a special kind of relation called a function. And the reason is because all of the inputs, they call the x values inputs, all of the inputs have exactly one output. Okay, give me a second, the phone's ringing, I'll be right back. Hello? Uh-huh. Hey, how you doing? Uh-huh. Uh-huh. Okay. Uh-huh. Okay. Okay. Yep. Yep. Okay, yeah, I was wondering, because I know that I had a list of all the kids that signed up, and last week, any kids that were missing any forms, I had them sent over to the school, and had them bring them home, and he apparently brought them home and got them filled out and signed and brought back, but then he didn't come to practice that day, so I didn't really know what was up with that. Okay. 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 Now it's 4 to 6 tonight though. It's not 3 to 5. It's 4 to 6. So, and it'll probably be 4 to 6. Yeah, tomorrow 4 to 6 as well. So, okay, we'll see you, Amanda. Bye bye. Okay. Sorry about that, guys. This thing's still going. Yes, it is. Okay, so let's look at question number. Oh, exactly one. Every input has exactly one output. Okay. Let's look at question number 5. Question number 5, what do we got here? Okay, this is a different kind of a drawing, but it's the same basic thing. They give you a box where it has inputs and a box that has outputs. And when you look at it, we have the numbers, what, 0, 1, 2, 3, 0, 1, 2, 3, and then we have negative 3, 0, 3, 3, 0, 3, 2, 1. Okay. And then we have, now they have a line from 0 to negative 3. That's good so far. This input has only one output. Okay, then it has 1 is going to 0. That's good. That's the only thing that 1's paired up with, which is 0. Then we have 2 going to 3 and to 2. That's no good. This input has 2 outputs, so it's not a function. The last one has 3 going to 1. It doesn't really matter. This is not a function. Okay, because there's an input that has more than one output. Okay, this is not a function because one or more, when you're filling in the blanks on your assignment, one or more inputs has 2 outputs. Okay, so this is a different way of explaining what a function is. Okay, let's look at number 7. Okay, again, this one right here, they're asking us another way of having this. This is number 7. We have input. I think they have next to it in the output. Your y values. And what do they give us here? So we have the inputs. We have 16, 1, 0, 1, 16, 1. And what? And 16 again. And the outputs are negative 2, negative 1, 0, negative 2, negative 1, 0, 1, and 2. Okay, so they ask us, is this a function? Well, we look to see if there's any input that has more than one output. Well, we see 16 is paired up with negative 2, but 16 is also paired up with positive 2. Okay, that would not be a function then. Plus, 1 is with negative 1 and 1 is also with positive 1. Okay, 1 is paired up with 2 different numbers. This is not a function. Okay, it is not a function. And again, filling in the blanks because one or more of the inputs has 2 outputs. Okay? If it had 3 outputs, that'd be even worse. Okay? It can only have 1 output. Every input has exactly 1 output. Let's look at question number 9. Okay, question number 9. Is this a function? Okay, this is something we have not talked about. They give you a drawing. Okay, I'm going to draw over here a graph. Okay, this is something that's really, really nice. This is a very, very simple concept, I think. Okay, so they give us some points. This is number 9. And what do we got here? We got all the way up to 6 and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. And we have the points for 1. And we have the points 5, 5. And we have the points 1, 6, 1, 6. 2, 3, 2, 3, and 3, 4. 3, 4. Okay, now when you have a graph, the way you can tell whether a graph is a function or not is something called a vertical line test. Okay, vertical line test. Vertical goes up and down. Sometimes students mix up vertical with horizontal. Think about it. If you test your vertical leap, you jump up as high as you can, okay? So vertical means up and down, okay? So the vertical line test, what that is can you ever draw a vertical line and have it hit the graph in more than one spot? Well, if I drew it right here, it's only going to hit through this one spot. It's going to hit through one spot. It's going to hit one spot, one spot, one spot. That's good. That means it passes the vertical line test, okay? That is a function. It passes the vertical line test. Now, if I would have had another dot right here, this would not be a function, because if I drew a vertical line right here, it would hit two spots at the same time, two dots at the same time. That would no longer be a function because it would have failed the vertical line test, okay? So that dot's not there. Every time I draw a vertical line, no matter where I draw it, it's only going to hit it in one spot. That's good. It passes the vertical line test. It is a function, okay? So filling in the blanks, it is a function. And what else are we filling in the blank? Because no vertical lines can be drawn through more than one point in the graph. So just click on no. Okay, it passes the vertical line test. There is no vertical line that hits it in more than one spot. Number 11. Okay. Is this a function? Okay. I'm not going to draw this perfectly. Okay, you can look at it on your computer. They give us something like this. It goes like this, and it goes like this. Is this a function? Well, can I ever draw a vertical line and have it hit in more than one spot? Bam, right away. It hit there, it hit there. That's not good. That fails the vertical line test because it hits it in more than one spot. Therefore, it's not a function. That is not a function. It fails the vertical line test, okay? So it's not a function. And then filling in the blanks, it says because many vertical lines can be drawn. You only need one, okay? You only need one. Many vertical lines can be drawn through more than one point of the graph. You only, as soon as you have one, you don't need to have many of them, okay? I don't know why they put that in there for a choice. There are many. It's not just one. I mean, there's one, there's two, there's three right there. Okay, I could draw a whole bunch more if I really, really wanted to, okay? But that's not a function. Okay, let's look at number 13. Okay, two more to go. Now, if you're going to struggle with this, okay, this section, the last thing that we have to learn is probably the hardest concept, something called the domain and the range, okay? Domain and range. Domain is simply the x values that are used. The range are the y values that are used. Now, sometimes students mix those up. I don't care how you remember it, but here's how I remember it. Alphabetically, x comes before y in the alphabet, and D comes before R in the alphabet. So that's how I remember, okay? So if I was to give you something such as this, 2, 8, 9, 4, 3, 7. The domain of this would be 2, 9, and 3. The x value, the x value, and the x value. The range would be the y values, 8, 4, and 7. 8, 4, 7. That's all it is. Domain are the x values, which are left and right. The range are the y values, which are up and down. So when you look at number 13, okay, they plot several points. So what it looks like is this. They want the domain and the range, okay? So we have -2, okay, and the point -1, 0, and the point 1, 0, and the point 2, 2, or 2, -2. Is there any other points on there? Yep. Okay. It might be easier if you actually name these points, okay? This point right here, we go 2 left and down 2, so that's -2, 2. This point right here, we went 2 right, and I'm sorry, -2, -2, I'm sorry. 2 left, 2 down would be -2, -2. This one's 2 right and down 2, so that'd be 2, -2. This is just 1 to the right and up none, so 1, 0. This is 1 to the left and up 0, so -1, 0. This is simply up 2, so that's 0, 2. Okay, so the domain. The domain are just the x values. Now, if I list off the x values, they are -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. The range are the y values. Now, the y values are -2, 0, 2, and then it has 0. Do we need to put it again? No. If you want to, you can, but you don't need to. And then we have -2. We've already got that on there, so you don't need to put it. If you see it twice, you only have to write it once. Okay? So that's what the domain is. And the range. Last one, and this is where it gets even trickier, okay? Number 17. I'm sorry, number 15. Is 15? Yeah, number 15. Why is it 17? Number 15. All right, this is something called a discrete graph, by the way. A discrete graph is when when you draw the graph, you put your pencil on the paper, then you have to take it off and do more. Like I would put this marker on there and take it off, and put it right here, take it off, put it right here, take it off. I have to keep putting my marker on the board over and over and over. A continuous graph, you can do the entire graph without taking your marker off the board. So we have it -4. And what? -4, 6. And then we go to 2, 3. Okay. So they give us something like, this looks terrible. Let's see. 2, how high do we go? Goes to 3, so it goes down to 2. Goes sort of like this. This is what I'm talking about. When I did this graph, I went shh, like that. I could do it all without taking my marker off the board, okay? I mean, yes, I put the dots there and then I did it, but I mean, I connected them with one continuous. That's called a continuous graph, okay? So you can't name all the points like we did here because there's literally, it looks like there's only 2 points on this. There's actually an infinite number of points on this, okay? I only plotted the beginning and the end of it, okay? Well, we can't write an infinite number of points. That takes forever, literally, okay? So here's what you do for the domain. On a continuous graph, you look at the graph left and right. That's the x values. Domain is the x goes left and right. What's the farthest to the left that this got to? It got to -4. And then you leave a blank and you put x. And how far to the right did this go to? It got to 2. Leave a blank and put 2. It had to be everything bigger than -4, but smaller than 2. And these were open dots, were they? I think, or closed dots, I mean. So we have to put equal signs under them. So the domain is from -4, between -4 and 2, including -4 and 2. Now, a lot of students don't have too much problem with that. Where they really struggle is the range. For domain, you look at the graph left and right. For the range, you don't look at it left and right, you look at it up and down, up and down. So we do the same thing. On the domain, we went smallest to biggest. We do the same thing with range. Go from smallest to biggest. What's the lowest this thing got to? Well, it got as low as, this right here was a 3, and this right here was a 2. Okay? It got as low as 2. So we're going to put 2, leave a blank, put a y this time, not an x. Range is all about the y values. Leave another blank, and what's the highest this graph ever got to? It got as high as 6. So leave a blank, put 6. Then you still put less than or equal to signs. Okay? So that's domain, that's range. It's a lot more difficult to do the domain and range on a continuous graph. A lot of students struggle with that, okay? All right, I think that's the end of this assignment. Okay, give me a second here. Again, sorry about that. What do we have here? This thing is due, what does this one do? 3-1, Monday. Okay, so this section, it really shouldn't take you that long, I don't think. But I'm going to give you till Monday, okay? This thing is due on Monday, I believe. Section 3.1 is due on Monday. We're going to start section 3.2 on Tuesday of next week. And you'll have your next video, or section 3-2 that hopefully you'll watch next Tuesday. Probably about sometime Tuesday afternoon is when I'll probably post that. So I'll probably make the videos Tuesday morning and then post them Tuesday afternoon, okay? So anyhow, if you have any questions, make sure you email me and ask. Okay, hope to see you guys soon.